Question number 27. A soap bubble blown by a mechanical pump at the mouth of a tube increase in volume with time at a constant rate. तो वॉल्यूम यहाँ पे कांस्टेंट रेट से बढ़ता जा रहा है सोप बबल का. द ग्राफ दैट करेक्टली डिपिक्ट्स द टाइम डिपेंडेंस ऑफ प्रेशर इनसाइड द बबल इज गिवन बाय. So let us solve the question. Question number 27. Pressure inside is equal to pressure outside of the bubble plus 4T by R, where T is surface tension and R is the radius of the bubble. This is the excess pressure 4T by R. We are given that volume is increasing at a constant rate. So I am assuming volume as a function of time, and V is given by some constant K into time T. So the rate is K. D by dt is equal to K. It is constant. K is a constant. We have to calculate R in terms of time to put here. Volume is 4 by 3 pi R cube. This is equal to KT, and this R will be 3 KT by 4 pi, this whole power 1 by 3. Basically I can write it as some constant multiplied by T की power 1 by 3. Let us put this here. P inside is equal to P outside plus 4T by R is some lambda which is constant, T की power 1 by 3. Some graphs are given. In the first graph, P versus T. So obviously P inside versus T, there is no direct relation. T is coming down, so it cannot be a straight line. Log of T, again it cannot be a straight line like this, which having increasing slope. 1 by T, there is no 1 by T here, and 1 by T cube, there is no T cube here also. So in my opinion there is no correct answer. The last option, option number 4, would have been correct if the graph is drawn between P versus 1 by T की पावर 1 by 3. तो अगर ये होता तो उस केस में ये ग्राफ सही हो सकता था, लेकिन यहाँ पे T की पावर 3 दिया हुआ, तो this is also incorrect. So none of the options is correct for this question. Question number 28. To double the covering range of a TV transmission tower, its height should be multiplied by. So it is from communication. Question number 28. This is the Earth's surface with curvature, and here there is a transmission tower, and it is the range where it becomes tangential. It is the center of the Earth. This is a radius. This is, let's say, height, and let us make this diagram like this. And range is suppose D. Using Pythagoras theorem, R square plus D square is equal to R plus H square. R square plus H square plus 2RH. It is R square plus D square. This R square is cancelled, and this D square is H square plus 2RH. This term is negligible as compared to this term, so we can neglect this term, and D is under root 2RH. So this range D is directly proportional to root H. To double the covering range, if we want to double this, we have to multiply H by 4 times. It should be 4 times. So the correct choice is option number 2. 29. A parallel plate capacitor with plates of area 1 meter square each at a separation of 0.1 meter. The electric field between the plates is 100 Newton per Coulomb. The magnitude of charge on each plate is. So it is a question from capacitor. These are the two plates of the parallel plate capacitor. Let us charge on these plates as Q and minus Q. electric field is given by Q divided by A epsilon naught, and then Q is given by EA epsilon naught. All the values are given. E is 100, area is 1 meter square, epsilon naught is 8.85 into 10 to the power minus 12. So it is a very simple question, 8.85 into 10 to the power minus 10 coulomb. This is the answer to this problem, and the correct choice is option number 4. Question number 30. In a Frank-Hertz experiment, an electron of energy 5.6 electron volt passes through mercury vapor and emerges with an energy of 0.7 electron volt. The minimum wavelength of photons emitted by mercury atoms is close to. So this is electron with certain energy 5.6 electron volt, and it is passed through this mercury vapors. There will be many atoms in this mercury vapor, and electron finally comes out with kinetic energy of 0.7 electron volt. That is, loss of kinetic energy is 5.6 minus 0.7. This is 4.9 electron volt, and this kinetic energy must be used by the vapor atoms to excite their electrons. And when electrons are excited, when they return back and they emit some radiations, some wavelengths of photons, we have to calculate. The key point is that we have to calculate the minimum wavelength. Minimum wavelength corresponds to maximum energy photons. To calculate this, we will assume that electron has lost 4.9 electron volt, and this loss is given to a single electron. This loss is given to a single atom, and that atom is excited. If this energy is completely given to a single atom, then photon of maximum energy will have minimum wavelength, and this lambda minimum is 1240 divided by 4.9, and this will give the lambda in nanometer, and on calculation this is approximately 253.06 nanometer. So the correct choice, which is very close, is 250. 250 is close to this answer. So option number 3 is correct.